Hi everyone, this is Ramalinga Prasad Gupta. Welcome to my channel Pharma World. Today's topic is interpretation of pharmacopoeia monograph. Understanding and interpretation of content in an article of pharmacopoeia is important. Unless the intent is understood fully, you are likely to carry out the test in a wrong way. The testing output will be erroneous and inconsistent. Let us understand the intricate articulation of a typical pharmacopoeial monograph in this video. Understand carefully and fully. Let us understand what is a compendial monograph or a compendial article. By definition, compendia means compilation of complete information on a specific product. It is a complete compilation of a specific article in a pharmacopoeia. It consists of several tests, test methodology to execute, acceptance criteria for the specific article. These are common generic tests that are required to be complied with. You may have additional physical tests like bulk density, particle size, etc. Compilation is done after a detailed validation and documenting the necessary data. The entire test procedure is validated as per USP Chapter 1225 and documented fully. Then it is submitted to the compendial forum. After review and approval of the entire validation documentation, it is included in the compendia. The expert team of Pharmacopoeial Forum reviews the entire validation docket for adequacy of data before publishing in the compendia. The compendial monograph refers to the pharmacopoeial monograph. Generally, a pharmacopoeial article is called a compendial monograph. There are specific test requirements and acceptance criteria for confirmation. Generally, the list includes appearance test, more than one identification test, list of impurities by HPLC or GC, SA, LOD or water content by Carl Fisher, sulfate dash, etc. to name a few. Let us see one typical example. This is the empirical formula. This is the molecular weight of the product. This is unique identification number. CAS is a unique numerical identifier assigned by the Chemical Abstract Services CAS US to every chemical substance described in the open scientific literature. You will see such unique numbers for any chemical entity. This is the structural formula. This is another name for the formula. Dried basis means LOD correction should be done. LOD includes residual solvents also. When it is claimed as anhydrous, the Carl Fisher, that is the water content correction, should be applied. So SA calculation should be done as SA percent SH multiplied by 100 divided by 100 minus percent LOD. So when there is a requirement to calculate the SA on the dry basis, this should be the rule. The packaging conditions prescription is that the primary and secondary containers should be sealed airtight, heat sealed or fastened with a cable tie to avoid accidental exposure to the external moisture. Storage should be in a cold place. As per USP 659 chapter, the recommendation for cold is not exceeding 8 degrees Celsius, that is 46 degrees Fahrenheit. These are basic requirements for packaging and storage. One important point to note is that it is not packing, it is called packaging. Packaging includes specific primary package, specific secondary package, specific type of sealing, specific type of label, etc. All are specific to that particular product. You can notice in any guideline it is referred as packaging only and not as packing. Whenever there is such a reference, it should be understood that the reference standard should meet the requirements as per chapter 11 of USP. Any secondary standard used in place of US reference standard, it should be qualified against the US reference standard as prescribed in chapter 11. This is a measure of location of the spot. RF means retardation factor. This is used for TLC test. This is similar to relative retention time in HPLC or GC. This is the ratio of the distance moved by the spot from the point of injection divided by the distance the solvent front moved. Since the spot cannot go beyond the solvent front, the RF value is always less than 1.0. In HPLC or GC, peaks appear after the main peak also. So you will also have more than one RRT. The IR test should be done as prescribed in USP 197K. Calibration of equipment should also be done as prescribed in 197K chapter. How do you do this test? Did you see the prescription in USP 641 chapter? See this. You have to carry out the test exactly as prescribed in this. You have to take the prescribed 10 ml glass cylinder, fill almost to the constriction at the neck, and then shake gently for completion of dissolution. Color of solution should not be more than 0.10 when carried out as prescribed. Chapters 731 to 81 and method 2 of 231 chapter should be followed in total as prescribed. For solvent preparation of dichloromethane and methanol in 1:1 ratio, you have to take one volume of each for the mixture. You have to understand one point here. You should always mix one volume of each for solvent preparation. If you take, for example, 50 ml of dichloromethane, you have to take 50 ml of methanol and mix them. You cannot measure 50 ml of dichloromethane into a 100 ml measuring cylinder and make it up to 100 ml with methanol. These two types of mixings are not same. You can check that these two types of mixings will give different final volumes. For solution A, you have to take 5 mg of standard and dilute to 10 ml. This would give you 0.5 mg per ml. Take 3 ml of the solution and dilute to 10 ml in another flask to get 0.15 mg per ml solution, that is solution B. Take 1 ml of solution A and dilute to 10 ml in another flask to get 0.05 mg per ml for solution C. These intricate details have to be captured into your SOP or STP. Quantitative means you have to use A-grade calibrated pipette for these dilutions.
Similarly, there should be details in the SOP on how to prepare these test solutions and identification solution, how much to take, how much to dilute, etc. You should read this chapter completely and understand it fully. This is very important. I explained in several video training programs on importance of this chapter. You have to read again till you understand completely to become a good chromatographer. Until you understand the USP 621 chapter, never touch TLC, GC or HPLC, to that matter any chromatographic techniques. You get similar information in EP 2.2.29 and 2.2.46 also. You have to use a flat-ended microliter syringe for spotting. Care should be taken to spot in several smaller increments, drying out the solvent using a hand dryer. Never allow the diameter of the spot beyond 3 or 4 mm. You get good spots. This is important point. You have to follow exactly like this for better results. Mixing in this ratio is similar to the reasoning as given above. Ammonium hydroxide, you have to use ACS grade material for better results. Always use AR grade ammonia for this test. The specific gravity should be around 0.88 to get better results. For short wavelength UV light, you have to use 254 nanometers. You use a UV cabinet for this. Never stare at the UV lamp directly. It can damage the retina of the eye. Use only in the chamber as a reflection on TLC plate. It is also recommended to use goggles for viewing the spots in the UV chamber. Here you are comparing the spots from the test solution chromatogram, that is 50 mg per ml solution. Any secondary spot is not darker than the spot of the standard B, which is 0.15%. If you calculate on the sample basis, the result would be 0.15 mg into 100 divided by 50, that is equal to 0.3%, because 50 mg is the test sample weight. All other secondary spots have to be not more than 0.10%, that is 0.05 mg into 100 divided by 50 mg, that is the sample weight. That will be equal to 0.10% individually, and sum of all such impurities should not be more than 1%. Each individual impurity is compared with secondary solution C, that is 0.05 mg per ml. So the interpretation is that any individual impurity should be less than 0.3% compared with the standard solution B, and sum of all impurities more than 0.1% compared with the standard solution C should be not more than 1%. Concentration of solution A is 1% on the sample concentration, that is 0.5 mg into 100 divided by 50 mg, that will become 1%. See the content understanding in these 8 lines of the text. All these details should be part of your SOP for testing. In pharmacopoeia, the entire monograph is covered in a page or two. But if you write a shop floor SOP, see how many details are required to be captured. The SOP may run into several pages. Diluent, phosphate buffer, mobile phase, system suitability solution, and chromatographic system, you have to proceed as directed in the essay test. All the reagents have to be prepared as described in the essay test. Details of reagents preparation are given in the next slide. The test solution preparation has to be prepared as explained in the earlier slides. See this point, you have to run the chromatogram for 2 times the retention time of the main peak. For example, if the retention time of the main peak of omeprazole is 10 minutes,
It is necessary to run the analysis for at least 20 minutes. This is a simple calculation for impurities. In this type of calculation, the relative response factor for any peak is unity. This is also called area normalization method. Try to understand the formula. Take a commutagram, add up each area counts for all peaks. You get the total area as the last column. Divide each peak area by total area. You get percentage of that particular peak. Do similar calculation for the remaining peaks. Interestingly, add up all the percentages of peaks, you get 100%. This method of calculation is called area normalization method. Any peak should not be more than 0.3% individually and the total not more than 1%. So this is similar calculation as explained in the previous slides. For assay test, the reagents have to be weighed as prescribed here. The reagents should be taken to the third digit accuracy. This is important to get consistent results. Another important point is that the pH of 7.6 should be checked frequently to check that the pH is maintained throughout the analysis as prescribed. If the mobile phase reservoir is protected by plugging with a correct fit lid, possibility of change in pH during analysis can be avoided. Buffers should always be filtered to avoid any ingress of minute undissolved particles of salt or any other fine extraneous matter. It is recommended to use nylon filters of 0.45 microns. Generally, when HPLC grade solvents like acetonitrile are used, it is not necessary to filter. Degassing is necessary to expel any air bubbles in the mobile phase. The final solution should be 0.2 mg per ml. The final concentration of the sample is 0.2 mg. This is arrived by taking 100 mg in 50 ml, that will be 2 mg per ml, and this is diluted 10 times from 5 ml to 50 ml. You get a concentration of 0.2 mg per ml. System suitability solution prepared to get a concentration of 0.1 mg per ml of the standard. A 4.6 into 15 centimeters column that contains 5 micron packing of L7. It is necessary to study USP 621 or EP 2.2.29 and EP 2.2.46 or any other pharmacopoeia to understand the necessary stationary phases. The reference here is only generic. You can find the list of stationary phases in USP. There is generic list in USP. You can get entire list from the column suppliers also. Here L7 means octyl silane C8 column chemically bonded to porous silica. There are hundreds of L7 columns from several suppliers. You can use any suitable column of L7 with prescribed dimensions. All these system suitability requirements have to be met. As explained in the previous slide, some parameters may be marginally adjusted to see that the system suitability passes. See, this is an interesting calculation. It is 500 into C into test area by standard area. In this, C is 0.2 mg per ml. That is 100 mg made up to 50 ml. 5 ml of the solution is further diluted to 50 ml, that is 10 times. So the final calculation looks like this. 100 mg is diluted to 50 ml, 5 ml is further diluted to 50 ml, 100 is taken for calculation of the percentage, the total value is 500. The other important points to note are the text in pharmacopoeia is not descriptive enough for benchtop analysis. There are several cross references in italics for reagents and other volumetric solutions. A detailed stepwise articulation should be made for the shop floor
to help the analyst to carry out the analysis without any ambiguity. I hope that you understood how to articulate the pharmacopoeia monograph. Unless you articulate the intent of each step carefully, you will not be able to execute the test to get consistent results again and again. It is necessary to get the benchtop action-oriented SOP with detailed steps for all such monographic articles. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.